When we do a calculation, the accuracy of the answer we get will depend on the accuracy of the numbers that we used in that calculation. And that's what we're looking at in bounds. So we're looking at the range of possible answers that we can get depending on how accurate the numbers we used in the calculation were. Let's look at this to start with. It says a length is measured as 106 meters to the nearest meter. Find the upper bound and the lower bound for the length. So if we've got 106 meters, the one up is 107 and the one down is 105. So it's the nearest meter, so it's going up in 1 meter each time. And we're going to say that the lower bound is halfway between 105 and 106, which is 105.5. And the upper bound is halfway between 106 and 107, which is 106.5. If we wrote this as an error interval, we'll say the length is bigger or equal to 105.5 and less than 106.5. It can take the value 105.5, so we write or equal, but it cannot take the value 106.5, so we don't write the or equal sign. However, I'm still going to say 106.5 is the upper bound and 105.5 is the lower bound. So you might think, why don't I use 106.49 as the upper bound? And that's because it's not the highest possible value. If I had 106.499, that would be bigger than 106.49. Or if I had 106.4999, that's even bigger again. And I can keep going adding nines on until I've got 106.49 recurring. So the 9 going on forever. So you might think, well, we'll use 106.49 recurring then. And 106.49 recurring is actually equal to 106.5. I'm going to divert slightly. 106.49 recurring. If we convert that to a fraction, so if we call that x, we're going to multiply it by 10 to get the 9 recurring by itself. And then multiply by 10 again to get something else ending in 9 recurring. If I take away, do 100x take away 10x, that will give me 90x. And if I do 10,649.9 recurring, take away 1,064.9 recurring, I get 9,585. So 9,585. And then divide both sides by 90 to get x by itself. And you'll see that we've got 106.5. So x is equal to 106.5. So 106.49 recurring is actually 106.5. So back to the point, we're going to call 106.5 our upper bound and 105.5 our lower bound. So let's look at finding the upper and lower bound for some questions. So the question is find the upper bound and the lower bound for these measurements. So question 1, we've got 3.2 to 1 decimal place. So 3.2, the one up is 3.3, down is 3.1. So the lower bound is halfway between 3.1 and 3.2, so 3.15, and the upper bound halfway between 3.2 and 3.3, 3.25. 410 to the nearest 10. So to the nearest 10, the one up is 420, the one down is 400. So the lower bound is halfway between 400 and 410, which is 405. The upper bound is 415. And 1.97 to three significant figures. So the one up is 1.98, the one down is 1.96. So the lower bound is halfway between 1.96 and 1.97, which is 1.965. And the upper bound halfway between 1.97 and 1.98, which is 1.975. Okay, three of these for you to try. So pause the video and give them a go. Okay, the first one we've got 15.64 to two decimal places. So up will be 15.65. Down will be 15.63. So our lower bound is halfway, which is 15.635. And our upper bound, halfway again, 15.645. 25 to the nearest 5. So the one up is 30, the one down is 20. So our lower bound will be 22.5, and our upper bound 27.5. And 2,000 to one significant figure. So the one up is 3,000, the one down is 1,000. So our lower bound is halfway, which is 1,500, and our upper bound halfway, which is 2,500. So let's take a look at a bounds question. A field has a length of 102 meters to the nearest meter and a width of 57 meters to the nearest meter. Find the upper bound and the lower bound for the area of the field. So the area of a rectangle, let's assume it's a rectangle, is going to be length times width. And to work out the bounds, the upper bound and the lower bound, we need to work out the upper bound and the lower bound of the inputs into the calculation. So for the length, it's measured at 102. The one up is 103. The one down is 101. So the lower bound is halfway between 101 and 102, which is 101.5. And the upper bound is halfway between 102 and 103, which is 102.5. For the width, it's 57 meters to the nearest meter. So the one up would be 58, the one down would be 56. So the lower bound is halfway between 56 and 57, so 56.5. And the upper bound, halfway between 57 and 58, so 57.5. So the upper bound for the area, I would write upper area, is going to be the biggest length times the biggest width. So that's going to be the upper length times the upper width. So the upper bound for length is 102.5 times the upper bound for width, which is 57.5. So we can type this into the calculator, and that will give us our upper bound for the area. So 102.5 times 57.5, and that is 5,893.75. So 5,893.75, and it's meters, it's an area, so it's meters squared. To get the lower bound for the area, we're going to get the lower length times the lower width. So it's going to be 101.5 times 56.5. So again, type it into the calculator. And this time we've got 5,734.75. And again, meters squared. Okay, here's one for you to try. So pause the video and give it a go. A circle has a radius of 5.2 centimeters to 1 decimal place. Find the upper bound and the lower bound for the area of the circle. So the area of a circle is pi times the radius squared. And we need to know the upper and lower bound for the radius. So it's been measured at 5.2. The one up is 5.3. The one down is 5.1. So the radius is in between 5.15 and 5.25 centimeters. So to get the lower bound for the area lower, we're going to take pi times 5.15 squared. So pi times 5.15 squared. And for the upper, it's going to be pi times 5.25 squared. So pi times 5.15 squared. I'll give this answer to 2 decimal places. So 83.32. And that's centimeters squared to 2 decimal places. And for 5.25, the upper bound, 86.59. So 86.59 centimeters squared, again to 2 decimal places. Let's look at a different example. A car travelled 543.4 meters to 1 decimal place in 28 seconds to the nearest second. Find the upper bound and the lower bound for the speed of the car. So speed is equal to distance over time. Whenever we have a division in a bounds question, we need to be careful, because dividing by a smaller number usually gives us a bigger answer, and dividing by a bigger number usually gives us a smaller answer. So to find the upper speed, I just write US, we're going to take the upper distance and divide by the lower time. So dividing by a smaller number is going to give us a bigger answer. And to find the lower speed, we're going to take the lowest distance and divide by the upper time. So dividing by a bigger number is going to give us a smaller answer. So let's work out the upper bound and lower bound for our distance and time. So for distance, we've got 543.4 meters. It's to one decimal place. So the next one up is 543.5. The one down is 543.3. So the lower bound is 543.35. And the upper bound, 543.45. And for the time, so it's 28 seconds. The one up is 29. The one down is 27. So the lower bound is 27.5. And the upper bound, 28.5. So our upper speed, upper S, is going to be our biggest distance. So 543.45 divided by our lowest time, 27.5. And our lowest speed, so lower S, is going to be our lowest distance, so 543.35 divided by our biggest time, 28.5. So we'll type these into the calculator. So we've got 543.45 over 27.5, which is 19.76 to 2 decimal places. And it's in meters per second, 2 dB. And our lower speed, (543.35) over 28.5, 19.06. 19.06 meters per second, also to 2 decimal places. Okay, one for you to try, so pause the video and give it a go. A cyclist travelled 349 meters to the nearest meter in 65 seconds to the nearest second. Find the upper bound and the lower bound for the speed. So again, we've got speed equals distance over time. And to find the highest speed, we're going to do the upper distance divided by the lowest time. And to find the lowest speed, it's going to be the lowest distance in the biggest possible time. So let's look at our distance. So 349 to the nearest meter. So the one up is 350. Down one is 348. So our lower bound, 348.5. And our upper bound, 349.5. So that's our distance. For our time, so it's 65 seconds. The one up is 66. One back is 64. So our lower bound is 64.5. And our upper bound 65.5. So our upper speed is biggest distance divided by smallest time. And our lower speed is smallest distance divided by the biggest time. So let's type these in. So I've got 5.42. So 5.42 meters per second to 2 dP. And for the lower bound, 5.32. meters per second to 2 dB. One more example. This time the question says, by considering bounds, find the answer to a suitable degree of accuracy. So that means we're going to calculate the lower bound and the upper bound and see what they both round to. So we've got a block of wood has a mass of 95.3 grams to 3 significant figures. So we've got 95.3. The one up is 95.4. The one down is 95.2. So we can say the lower bound is 95.25 and the upper bound is 95.35. The volume is 215 centimeters cubed to the nearest whole number. So it's 215. The one up is 216. The one down is 214. So 214.5 is the lower bound and 215.5 is the upper bound. We need to find the density. So density equals mass over volume. So like the last question, to find the upper density, it's going to be the biggest mass divided by the smallest volume. So density upper bound. So upper density is the upper mass divided by the lower volume, and the lower density is the lowest mass divided by the upper volume. So let's look at these bounds. So for the upper bound for density, so upper D, it's going to be the biggest possible mass, which is 95.35, divided by the smallest possible volume, 214.5. So to get a bigger answer, we're dividing by a smaller number. And the lower bound for density is going to be the smallest possible mass, 95.25, divided by the biggest possible volume, 215.5. So let's put these in the calculator. So 95.35 over 214.5. So that's 0. I'm going to write down as many as I can. So 0.44452. 0.44452, and so on. And the lower bound, so if I just go into the calculator and change these numbers, so I've got 95.25 over 215.5, and that's 0.44199, and so on. 0.44199, and so on. So a suitable degree of accuracy. So what does the lower bound and the upper bound both round to? So what's the biggest value of accuracy I can give? If I wanted 3 decimal places, that would be 0.444 or 0.442. So they're not the same to 3 decimal places. So I can't give my answer to 3 decimal places. To 2 decimal places, I've got 0.44 and 0.44. So I can say that the answer is 0.44 because the upper bound and the lower bound are both 0.44 to 2 decimal places. Okay, one for you to try. So pause the video and give it a go. A piece of metal has a mass of 12,400 grams to 3 significant figures, and a volume of 658 centimeters cubed to the nearest whole number. So we're going to find the density again. So the upper and lower bound for density. So we've got mass, which is the 3 significant figures. So the one up would be 12,500. The one down, 12,300. So the lower bound is halfway, so 12,350. And the upper bound, 12,450. For volume, we've got 658. The one up is 659. The one down is 657. Halfway for the lower bound, 657.5, and the upper bound, 658.5. So the upper density, upper density, UD, is going to be the biggest, so density is mass over volume. The biggest density is going to be the biggest mass over the smallest volume. And the lower density is going to be the smallest mass divided by the biggest volume. So let's type them in. So the upper bound, I've got 18.935 and so on. And the lower bound, I've got 18.754 and so on. So what do they both round to? So to one decimal place, I've got 18.9 and 18.7. So that's not the same. To the nearest whole number, I've got 19 for them both. So I can say they're both 19. And I've completely missed off the units here. So it's grams per centimetre cubed. 19 grams per centimetre cubed. And that's to the nearest whole number, or 2 significant figures. All right, 2 significant figures. Okay, let's finish up with 2 questions. So pause the video and give them a go. Question 1. N is 2.52 to 2 decimal places. Find the upper bound and the lower bound for n. So we've got 2.52. The one above is 2.53. The one below is 2.51. So the lower bound is 2.515, halfway between 2.51 and 2.52. And the upper bound, halfway between 2.52 and 2.53, which is 2.525. Question 2. So A is equal to B over C, where B is 2.7 to 1 decimal place, and C is 1.23 to 2 decimal places. Find the upper bound and the lower bound for A. So we've got B, which is 2.7. So the one up is 2.8. The one down is 2.6. So it's got a lower bound of 2.65 and an upper bound of 2.75. And C is 1.23. So the one up is 1.24. The one down is 1.22. So it's got a lower bound of 1.225 and an upper bound of 1.235. So to find upper A, we're going to take the biggest B and divide by the smallest C. So to get a bigger answer, we're dividing by a smaller number. And to find lower a, we'll take lower b divided by upper c. So we've got upper b, which is 2.75, over lower c, which is 1.225. And we've got lower b, 2.65, over upper c, 1.235. So we'll type them both in the calculator. So we've got 2.24 for the upper bound to 2 decimal places. And for the lower bound, we've got 2.15 to 2 decimal places.